Hello guys, in this video we talk about the diabetes patient. We talk about the why the diabetic patient is at high risk. As the researchers, as the doctors say the diabetes patient is at high risk. Why the diabetic patient is at high risk? In this video we explain the everything. We explain the mechanism. Actually, if the diabetes patient catches the disease, what happens inside his body. And I would like to share one thing here. Some people is saying the diabetic patient can catch the disease very rapidly and the normal person cannot. So I would like to share one thing here. If I am, for example, I am a normal person, okay, here is another person, but the person is diabetic. If I have 90% to catch the COVID-19, the same thing happens to this person, the diabetic patient. The diabetic patient has also the 90% to catch that virus or catch the disease. It's not like that the diabetic patient can catch the disease very rapidly, or I'm not, or the normal person cannot. It's not like that. It is the same thing. But if the diabetic patient catch the virus, catch the COVID-19, so the diabetic patient face the so many complications. That's why the doctors or the researchers said the diabetic patient is at high risk due to the complications. Okay, and it's not like that the diabetic patient can catch the disease very fast. It's not like that. Okay, so stay with me and know about this topic. I think you should know about this topic because it is the important topic. It's the general topic. So here I draw the, first of all, pancreas. Okay, in pancreas there are present islets of Langerhans, as we know. In diabetic patient, it's in this video is type 2 diabetic patient, diabetes. Okay, it's not type 1. In this video we're talking about the type 2. So the pancreas, there are in diabetic patient there are present high level of ACE2 receptors in type 2 diabetic patient. I'm talking about that, why the ACE2 receptors are present in high amount in diabetic patient. So this is the pancreas. There are present islets of Langerhans. In islets of Langerhans there are present alpha cells, beta cells. There are different types of cells, but in this video we talking about mostly the beta cells. Okay, so this is the, suppose this is the beta cell. And this is the beta cell. First of all we understand that what is the job of the beta cell. Suppose this is the beta cell. This is the channel where the blood is coming. This is a beta cell. So the job of the beta cells is to measure the glucose level, how much glucose is present in the blood. Okay, so here, for example, here is the blood coming and this is the glucose. The beta cell measures, the beta cell actually measures the glucose level, and according to that the beta cell releases the insulin. If let's assume there is 20% of glucose, okay, according to this percentage the beta cell releases the insulin. Okay, now as I said, the pancreas, the diabetic patient, there are present the high amount of the ACE2 receptors. So here is the beta cell. They are present, suppose these are the receptors, these are the ACE2 receptors. ACE2 receptors help us to the when the virus comes, when the COVID-19 comes and binds with these ACE2 receptors. Okay, so this is the virus, this is the COVID-19 virus, and the COVID-19 virus comes and binds with ACE2 receptor, and the ACE2 receptor brings the virus inside. Now here the ACE2 receptor, the virus, when comes inside the beta cell, it damages the beta cell. Okay, so here one thing, when the virus comes and binds with the ACE2 receptor, the ACE2 receptor brings inside the this virus, and the virus damages the beta cells. Okay, so the beta cells, as I said, the beta cells are the measure the glucose level when if in diabetic patient there are as I said, there are high amount of the ACE2 receptors. So when the virus comes and binds with the ACE2 receptors brings it inside, and the virus damages to the beta cells. It damages the beta cells. Okay, it's the one thing. So why the ACE2 receptors? Here the question arises, why the ACE2 receptors is in large amount in diabetic patient? Because due to the hyperglycemia, large amount of the glucose, due to the large amount of the glucose, that's why these ACE2 receptors are present in diabetic patient. It's a one thing. Next, suppose this is the artery. Okay, this is the artery. The artery, there are present the endothelial cells. Okay, I cut the artery and make here the cutted piece. There are present the basement membrane. It's the basement membrane. So here are the endothelial cells, okay, of the artery. In diabetic patient, there are present the high level of glucose. Okay, so in endothelial cells there are present the proteins. The glucose comes and binds with these proteins, makes a bond. Okay, makes a bond with the proteins. The large amount of the glucose comes and makes, as the glucose present in the blood, when the blood comes and here are present the proteins, the glucose goes and makes the bond to the endothelial cells. Okay, so these glucose particles or this glucose goes under the endothelial cells or beneath the endothelial cell. There are present the other cells. Okay, there are present the other cells. So this glucose makes here a network. Okay, so when the glucose comes and makes the bond with the proteins, the glucose comes now under the or beneath the epithelial cells, and there are present the different types of cells. So the glucose makes here the network. Okay, and means and hijacks the cells. Okay, so now when, for example, there are the lungs. So here are present the lungs. Okay, in lungs there are present the virus. There are present, say there are present the COVID-19 virus. Okay, there are coming the artery. There are coming the artery. As there are present the virus in lungs. Okay, here are present, here are coming, here are in there are coming the artery. So here, for example, now here are the macrophage. I hope you heard the name of the macrophage and you know what's the job of the macrophage or the macrophage. There are present the there are actually the phagocyte cells. Phagocyte means they engulf the virus or they engulf the disease, whatever there are, the foreign particles. The macrophage cells, or there are the neutrophil cells, there are present dendritic cells. Those cells catch the disease or catch the foreign particles and destroy the foreign particle. So here are, suppose here are, just remove it first. This is the macrophage. This is a macrophage cell. So here the macrophage goes and kill this virus or destroy this virus. But this, there are present the artery, or there are present where the intestinal membrane, where the macrophage present. The macrophage goes and destroy this virus. When this goes, there are present, as I said, there are present the glucose molecules, and they makes a network type of thing in the artery. So when the macrophage goes here, okay, here, so the macrophage cannot go properly to reach this place, because when the macrophage goes here, it slips here. Okay, it slips due to the glucose molecules. There are present a high amount of the glucose. The macrophage goes, and but the macrophage slip there, because due to the glucose molecules present in the artery. Okay, so when the macrophage comes and goes to the, and it goes, this macrophage comes, and here is the place where it reaches, but it slips here. Okay, it slips here and go to the forward direction. But it is the place is here where the macrophage, where the virus is, because due to the high amount of the glucose, the macrophage slips. Okay, it slips here and go to the forward direction. It's in diabetic patient. This is the another thing in diabetic patient. So as we know, the macrophage is the phagocytic molecule. This phagocytic molecule goes, but due to the high level of the glucose, the macrophage slips and go to the forward direction. Okay, so the virus is doing here the job, its own job. That's another thing. That's why the diabetic patient is at high risk. Okay, I hope you understand this whole thing. I give you the overview, okay, about the diabetic patient, type 2 diabetic patient, what happens inside if the diabetic patient catches the virus, and what happens inside his body. So due to the high level of the glucose, the diabetic patient faces so many complications. Okay, here the immune cells cannot function properly. Okay, there are the another things, there are the another process, like there are the acidic environment, there are the high fatty free fatty acids. So that's why the macrophage or the immune cells did not work very properly, or there are present those are the another process. In next video I will talk about that. So in this part I will talk about only, I give you the overview about this diabetic type 2 diabetic patient. When they catch the disease, what happens inside his body. So I hope you understand this whole overview. In next part we talk about the how the free fatty acids coming out, and what is ROS or S. There are also present free radical free radicals, and there are present high acidic medium. Okay, so in next part we talk about that, but I hope you understand this overview, and like this video, share this video, comment this video. Thank you.